All right. I love
Okay, welcome to a lesson on probability distributions. This is lesson 1. Let's get started. Make sure you like and subscribe to the channel. Nah, just kidding. All right, so in today's lesson, we'll learn what a probability distribution is. We'll also learn some terminology. This first lesson is mainly to give you an idea of everything. There's not much maths involved per se. It's mostly terminology. And yeah, let's get started. We're also going to distinguish between discrete probability distributions, which is what we do in year 11, and continuous probability distributions. So discrete versus continuous.
Ooh, scary.
Okay, so let's get started. You probably haven't never done this before, so it might be different and weird. Just bear with it. Let's get started. So let's say we toss a coin 3 times. What is the sample space? So we just finished doing that, right? We can draw a tree diagram. You'll get something like that. So you get heads, tails, heads, tails, heads, tails, and so on and so forth. Basically, you have 8 outcomes. You get head, head, head. You get head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and a tail, tail, tail. Any questions on how to read that and the 8 outcomes? Any questions at all?
Head, head, tail, 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 head.
No. Oh, good.
All right, let's move on. So that's sample space. If we were to list it out, we could list it out like that. Yeah, so it's like the head, 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 and that's listed over here, head, 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 and so on. All the 8 outcomes are listed. And this kind of tells you, where it's from and how to read it and so on. Anyway, moving on. Let's look at in more detail at the number of heads in each outcome. So what are we concerned about? Number of heads in each outcome. We don't care about tails, right? We're only looking at the number of heads.
Okay? We only want
so
heads.
We let X represent the number of heads observed when a coin is tossed 3 times. We're only concerned about the number of heads. Keep that in mind.
Yeah.
It's important. So X is a random variable, and we'll get to that in a second. How many heads in the first outcome? 3. So we said X is equal to 3. But in this outcome, X is equal to 2 because there are 2 heads. And then you have 2 heads here as well. So you have 2 heads. 2 heads here, 2 heads, and so on. Now, just worth noting, X equal to 3, 1 out of 8 in 1 out of 8 outcomes, X is equal to 3. In 3 out of 8 outcomes, X is equal to 2. In 3 out of 8 outcomes, X is equal to 1. And 1 out of 8 outcomes, X is equal to 0. I'm just talking about it, just discussing it, noticing patterns, noticing trends. There's nothing really to learn here per se. We're just looking at it, right? Okay, moving on. Now from the table, we can see that the possible values of X are 0, 1, 2, and 3. Right? X can be 0, 1, 2, or 3. All right. Now, since the actual value, this is important, this is the definition that you need to understand and learn and memorize. Since the actual value that X will take is the result of a random experiment, X is called a random variable. In other words, this is what you memorize. A random variable is a variable whose values depend on outcomes of a random experiment. Okay, a random variable, we said let X equal to something or other. X is a random variable. The value of X depends on a chance experiment. What's the value of X? Well, it depends on the experiment. When we flip the coin 3 times, how many times did we get head? It depends on chance, it's probability. Okay, so a random variable is a variable whose values depend on outcomes of a random experiment. Any questions?
No.
Not really. Yeah.
Okay, so it's a definition.
No.
Make sure you know it. That's what a random variable is. Now, another thing before we go to the next slide, what type of values does X take here? What type of numbers are they? 0, 1, 2, and 3. What type of numbers are they?
No?
No, not prime.
Oh, whole numbers.
Yeah, whole numbers. I'll accept that. The whole numbers. That's good.
Indices.
Right, so,
Continuous.
no, they're not continuous. Oh, No, using the wrong word. They're discrete numbers. We're just going to stick with whole numbers. Okay, they're whole numbers. There's no decimals, no fractions. They're whole numbers or positive integers, or zero is not positive, but integers or whole numbers. Moving on. Now you have two different types of random variables. Okay,
Oh.
you have two types of random variables. Random variable is a variable whose values depend on outcomes of random experiment. Fine, fair enough. But a random variable can be discrete or continuous.
Oh.
What does that mean? What is a discrete random variable?
A secret.
Well, a discrete random
is
variable
straight to the
takes on
point.
whole number values,
Yeah.
like the one we just done, right? The outcomes of discrete random variables are countable. The outcomes are countable. 0 head, 1 head, 2 heads, 3 heads. You can count them. So examples would be the number of times we get heads when we flip a coin 3 times.
Sir. So if it lands on the side,
Yes.
that's half.
Pardon?
So you flip a coin and it lands on the side. Like
No,
standing
it's
up.
not. It's not gonna happen. When we're doing maths, we kind of ignore that. I know it can happen in the real world, but in terms
Whoa.
of maths, we ignore that possibility. We just say it's gonna be heads or it's gonna be
Yeah.
tails. Anyway, moving on. Even if you
Sorry,
could
I'm
land
gonna
on the
bash you
inside,
after
it
you
would
said that.
still be a third possible outcome. It would still be countable. It would still be discrete. Anyway, the number of heads, number of times we get heads when we flip a coin is a discrete random variable. The number of children in a family. Can you have 1.5 children?
No,
No.
sir, unless they have dwarfism.
No. The number of children in a family, it's 1 child, 2 children, 3 children, it's going to be a whole number value.
Sir. There's a disease where someone has 3 heads. Isn't that 1.5 children?
No, it's still one
No,
person.
it's not.
The number
Oh.
of brown eggs in a carton of a dozen eggs. How many eggs can you have in a carton of a dozen eggs?
12.
It's countable, right? It's discrete, whole numbers.
Yeah.
Yeah.
The number of brown eggs in a carton of a dozen eggs. Let's say 6 of them are white, 6 of them are brown. 6 brown is discrete, it's countable. Now we contrast this is different to continuous random variables, which can take on decimal values and fractions, and there's an infinite number of them. For example, to help you understand, what is the height of someone or the height of something? Something could be 160 centimeters tall, or it could be 160.000235 centimeters, or it could be that huge number, which I can't be bothered saying. The point is, it's possible, right? It's a continuous, it's something that is continuous.
7.357.357.4 centimeters.
Thank you very much, Salman.
It's your height.
And so,
Bro, I'm taller
height
than
of
you, bro.
something, it's possible.
None of you
It's
talk yet.
possible to have absolutely any number whatsoever here. There's an infinite number of numbers which height could take. Whereas the number of times we can get heads, it's just going to be a whole number, 1 or 2 or 3 or 4,
Yeah.
But the height of someone in the year 11 classroom, the height of people in the year 11 classroom, I mean, if you had a measuring instrument accurate enough, and you could theoretically
180.
go as much as you want.
Yeah.
I hope that makes sense. Same with weight, and same with the time taking the complete a puzzle. So in general, these are countable things. These are measured things. We count these. If you count it, generally, it's going to be a discrete random variable. And if you have to measure it, it's going to be a continuous random variable. Now we do these, we do continuous variables in year 12. We're only concerned with discrete random variables in year 11. Okay, moving on, unless you guys have any questions.
No.
Discrete is whole numbers. Continuous is thing. Just
Yep,
decimals.
and you don't have to worry about these till year 12, okay? So we're just going to be doing discrete whole number stuff in year 11. All right, moving on.
Okay.
All right. The probability of random variables. Now we're getting to the probability side of things. We know what a random variable is. Now, what does probability have anything to do with this? Let's have a look.
So I
we
know.
Yeah.
So remember how you said like there's 2 times where x equals 2? So now you're gonna do that.
Yeah,
Huh?
that's right. So we can work out the
Yeah,
probability of a random
boy!
variable taking on a certain value. Let's go back to our example from earlier. We're tossing a coin 3 times. We're interested in the number of heads we obtain. The outcome, this is the exact table we had before. As you can see over here, the number of heads is 3. There's only 1 of them. The probability of these are as follows. right? But we notice that x equals 2, it happens 3 times. So we can summarize that and just say 3/8. The probability, and actually that's the next thing. P of x equals to 3 is 4/16 is read as, this is the way we read it, we say the probability, so you should be looking over here, right? The probability that the random variable x takes on the value 2 is 3/8.
Yeah.
Okay, the probability that the random variable x takes on the value 2 is 3/8 or 3/8.
Yeah.
Questions?
Good.
All right. And so before we go to the next slide, I just want to slow down and have a look at this table. What actually we do? We listed out all the outcomes. And then we looked at, we put it into numbers. We said the number of heads x is equal to 3, x is 2, 2, 2, 1, 1, 1, 0. Right. And then we just summarized them. We wrote the associated probability for each row. And we collected similar outcomes, and we wrote that.
Yeah.
Okay, moving on. This is probably going to be something in the homework, probably. Anyway, moving on. Probability distribution. How are the values distributed? Now, the list of all possible values of the random variable x, together with the probability associated with each value, is known as the probability distribution of x. Okay, read that again, make sure you understand it. The list of all possible values of the random variable x. Okay, and we're going to look at an example in a second. But do you remember you can draw a table basically, and that this is what they're referring to. X, P of x is equal to x. And x is equal to x. And then you have how many different ways could you get 0 heads?
0 heads, 1.
50%.
No, when we flip a coin 3 times, it was 1/8. If you guys
Oh, I
remember.
don't remember.
And the probability that number of heads is 1, 2, or 3. What's the probability that it was 3? Does anyone remember?
1/8.
1/8 as well. And this was
3/8.
8. We can go back to the previous slide and check. See,
Yeah.
number of heads is 2. It's 3/8. So 1/8, 3/8, 3/8, 1/8.
Yeah.
Okay, 0, 1, 2, 3, 1/8, 3/8, 3/8, 1/8. And so we come back over here, and that was 3/8 as well. And this is known as what? The probability distribution of x. It's the outcomes underneath the probability associated with each outcome in a table. That's known as the probability distribution of x. Okay, so we would summarize it in a table. And the first row, we write all the possible values that the variable x can take. X can take the values 0, 1, 2, and 3. How many heads are you going to get if you flip a coin 3 times? Get 0 heads, 1 head, 2 head, or 2 heads, or 3 heads. You can take those values. Yes?
If you get 0 times, so wouldn't it be 0/8?
No, the possibility, the probability that you're going to get 0 heads, in other words, you're going to get tails, 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 is 1/8, isn't it?
Yeah, got it now.
It's possible to get 1/8. And so we have x, x will be 0 heads, so sorry. So in the first row, we'll write the possible values. In the second row, we write the probabilities that x will take for each of these values. And 0 heads is 1/8. Okay, so just in case you forgot it, we'll go back over here. Tail, tail, tail. X is going to equal to 0 because there's no heads here, it's 0 heads. And the probability is 1/8.
Yeah, got it.
Yes, Salman, sorry, what are you saying?
Isn't the same thing as the one on the previous slide?
Yeah, but so that was kind of to explain, this is how we actually do it. So this is how you actually do it, okay? In your homework and so on, and moving forward, this is how you're going to do it, because we're going to be building on this stuff a fair bit. And there's going to be like 3 or 4 different rows more.
Oh, cool.
So as we move further into the chapter, we're going to build on this. You have to be very strong with this, understand this, because we're going to be doing all sorts of stuff in the next couple of days.
So this is the foundation.
This is the foundation. This is the basic, yeah. And then you multiply this with this, and you get the next row, and then you
Yeah.
add them all up, and
Yeah.
you will get to it. We'll get to it. Don't worry, we'll get to it.
Sir,
So just for now, understand this. In the first row, we write what? All the possible values, all the possible outcomes, and then you write the probability associated with each outcome in the next row.
So I think Dahi wanted to say something.
Yes, Tahir.
Sir, did you say you're not going to do the probability next year?
We're not going to do probability next term. I never said that.
Yeah,
Next term.
I asked you if you're done with probability, like forever.
Yeah,
like
this is not probability. This is, say we're done with probability. We're now doing probability distributions.
That was a trick, eh?
Yeah, so it's the same thing, but
It was a trick.
No, it's not really. Oh, it's similar. Okay, fine. It's similar. It's still statistics,
Sir,
I guess.
you know how much Dahi hates probability. Imagine how much he's gonna hate probability distribution. You're done, bro.
Look, don't say that. Just think
He's
the
finished.
best, and inshallah you'll be fine. All right, moving on.
I'm joking, sir. I'm joking. We all got this.
no.
Okay,
We're
so
finished.
listen. Since we listed out all the sample space, all the possible outcomes, and we wrote the probabilities of all of these, what should these probabilities add up to?
8.
8 out of 8. 1 out of 1. 1.
Yeah, that's what I said.
1. They should add to
Oh,
1.
yeah. So 8 of 8 is 1.
Because this is everything that's possible is written here, and obviously they have to add up to 1.
Yeah.
Okay. So the example we've just done is a simple case of a discrete random variable. This is a very simple question, but this is what discrete random variables are basically all about. It's you're looking at various outcomes and you're saying what's the probability of them? What's the probability of getting 1 head? What's the probability of getting 2 heads? Stuff like that.
Yeah.
Okay. Now there's one more definition one more term that we need to learn, right? That's uniform discrete probability distributions. If you were to graph the one we just done, we'd get 1 out of 8, 3 out of 8, 3 out of 8, 1 out of 8. Hopefully that makes sense.
They look like a car.
Yeah, it's kind of looking like that, and we'll build up to that in a second. We'll build up to it, you'll see. But it's looking like an upside down bell, more or less. But yeah, that's what it looks like. Uniform discrete probability distribution looks like this. Completely uniform, completely flat. So in this slide, I'm going to give you an example. It's called uniform if all of its values have the same probability. Simplest example is rolling a coin. If you roll a coin, what's the probability of each one? 1 over 6, right? It's very uniform. It's not 1 out of 8, 3 out of 8, 3 out of 8, 1 out of 8. It's 1 out of 6, 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 and so on.
Okay.
So the values are all equally likely, and its sample space is a uniform sample space. So for example, if a die was thrown and we were to list the probability distribution for the number shown on the die, we would get the following. All the possible outcomes in the first row. Quick revision, quick reminder. In the first row, we write all the possible outcomes. And the second row, we write the probability associated with each outcome. What's the probability of it being a run? What's the probability of rolling a 1? 1 out of 6. The probability of rolling a 2? 1 out of 6, and so on and so forth. Okay. And if you were to graph this, you will obviously get a straight line because they're all 1 out of 6. In the previous example, it was not.
Yeah.
Okay, so that's uniform discrete probability distribution. Uniform means the same. The word itself means the same. Obviously, when we go to school and we go to work, you have a uniform, which is something that you wear. But the idea of the uniform is it's exactly the same as everyone else.
Yeah.
I guess that's where the word uniform comes from. It means exactly the same. It's uniform. It's exactly the same. All the probabilities are exactly the same. All right, so that's the homework. We're done for today.
Oh, sweet.
The homework is exercise 11A.
Game.
Questions 1 to 3A, and so on and so forth. That's on the board. Please note them down, and then I will stop the recording.
Sir, game.
We'll see. I'm stopping the recording now.